So now we try to solve this differential equation. So once again, anytime you have it in the form m dx plus n dy is equal to 0, you first try to check that whether the equation is exact or not. So this, this part is m, this part is n. So you check my. My comes out to be 1 because the derivative of 4x squared is 0 with respect to y, and the derivative of y is 1. And nx, the derivative of this term will be 2x y cube with respect to x now. And the derivative of negative x will be negative 1. So they are not equal, so not exact. So if they are not exact, if an equation is not exact, you just don't give up. You go ahead and try to find one of those difference quotients and see if it's the function of the appropriate single variable. So let me show you that screen again. Okay, no, this was about exact equations, special integrating factors. So now, when it's not exact, we first check this difference quotient, my minus nx over n, and see if it's a function of x only or not. So let's see, my minus nx over n. Equals 1 minus 2xy cubed minus 1 divided by n, and n was this factor, the x squared y cubed minus x. So we want to see if this is a function of x or not. If this is a function of x or only, and there is no y, then we are on track to get the integrating factor. But apparently it looks that we do have a y here, but we should not give up until we simplify. Let's see what happens when we simplify. So this is 1 minus this term plus 1, so that will be 2 minus 2xy cubed minus 2xy cubed, and in the denominator I have x squared y cubed minus x. Now I factor. So in the numerator I can factor a 2, and I get 1 minus xy cubed. And in the denominator, you see, if you factor an x, you get xy cubed minus 1, which is almost this, but with reversed sign. So it means we need to factor negative x. And then we get 1 minus xy cubed, where after factoring the negative x, I get a 1 from this term. So I have written this one as first, and then this one. So now we do see that it is a function of x only, and therefore if we go back to our rule, If this quotient comes as a continuous function of x only, then the integrating factor is e power this quotient dx. So integrating factor, you can say a function of x, or we know that. So integrating factor is e power the integral of this quotient, which is -2 over x, is equal to e power -2 ln x is equal to e power ln x power -2, so that we can cancel the e and ln to get x power -2. So if we multiply the original equation with x power -2, we get an exact equation. So what happens when we multiply this by x power -2? So each term, in fact, now let's copy this equation and multiply it by x power -2. So if we multiply, so we also had equal to 0. No, it didn't copy it completely. So there was a dy here, is equal to 0. Okay, so x power -2 was our integrating factor. So multiplying by x power -2 is the same as dividing it by x squared. So we divide the whole equation by x squared. So when every term is divided by x squared, you get this one just becomes a 4, and this is y over x squared, or y x to the -2. So we will have first term is just a 4, second term is y x to the -2 dx, and then in this term the x squared will cancel out and you'll have y cube minus x over x squared will be 1 over x. Now if your work is correct, then this equation after multiplying by the integrating factor should be an exact equation. So I won't check it here, you can check yourself, but I will just believe that my work is correct. And so this is an exact equation, and then we know that the solution is four plus y x to the -2. So you do m dx, and you do terms of n that are independent of x. So you ignore this term. So you just do y cubed dy. So now the integral here is 4x plus y x to the -1 over -1 plus the integral of y cube is y 4 by 4. Oh, not equal to 0. When you do the solution, then that's equal to c. Okay. So this will be 4x minus y over x plus y 4 by 4. 4x minus y over x plus y 4 by 4. Plus y 4 by 4 is equal to C. And now, once again, about the lost solutions. Remember, I mentioned in the previous video that when you multiply both sides of a differential equation by a variable term, then you can lose solutions, and sometimes you can also gain them. But here, because of the options they have, it will only be a lost solution or a no loss solution case. So let's see. We multiplied by, let's go back. We multiplied by 1 over x squared. And if you look at the original equation, this numerator was the original equation. So this part was the original equation. And in this original equation, you see, you can factor out an x from these two terms. So if you factor out an x, and when x is equal to 0, then this part is 0. And then when x is equal to 0, then dx is 0. And it means that x is equal to 0 satisfies this equation, because when x is equal to 0, the dx is 0 makes this whole thing 0, and the x is equal to 0 makes this and this term equal to 0. So x is equal to 0 is a solution. However, when you multiply by 1 over x squared, you get this equation. And if you look at this equation, then x is equal to 0 is not a solution here, because okay, at x equal to 0, this part is 0, this part is 0, so this whole thing becomes 0. But this one is not 0, because in fact this is even undefined at x is equal to 0. So what has happened by multiplying by 1 over x squared is that the original equation had a solution x is equal to 0, which we have lost. So the solution x is equal to 0 was lost.